On its face, carbon monoxide is an extremely dangerous gas, at least to humans. There are two reasons for this. One, given that it's toxic to humans, it's also somewhat insidious in that it has no color or odor, leading to easy accidental poisoning in people exposed to it. The other is that it's chemically active within the body, which is what makes it so toxic, essentially making the body unable to distribute oxygen. Up until now, it's been assumed that if carbon monoxide were detected in the atmosphere of an exoplanet, it would indicate that life probably did not exist there, at least as we can envision it. Not only because it can be outright poisonous to some biology, it would also serve as a ready source of carbon and energy for any life that can use it. Thus it was thought that it wouldn't stick around long in an atmosphere with microbial life present. But this is being rethought in a broader context. Are some assumptions we make about certain things that would seem to preclude life from existing on an exoplanet not set in stone as we might think? In a paper by Edward Schwieterman and colleagues, linked below, they modeled hypothetical exoplanet atmospheres that contain carbon monoxide, and found two interesting scenarios where life and carbon monoxide in high amounts might coexist, and that may have been the case here on Earth long ago. With Earth, carbon monoxide doesn't persist in the atmosphere very long, being destroyed by chemical reactions, but this may not have always been the case. Before the Great Oxygenation Event, there was little oxygen in Earth's atmosphere, and the Sun's luminosity was less than it is today. If there were higher levels of carbon monoxide at the time, and conditions here allowed it to build up more than today, it would have been maintained when simple life was everywhere on this planet. If that could happen here, then it should be possible on exoplanets. But there's another scenario that came from the modeling that might even be more interesting. In a planetary system centered on a red dwarf, such as the TRAPPIST-1 planets or Proxima b, it may be easier to create and maintain carbon monoxide, and that oxygen-rich planets with high abundances of carbon monoxide could also host life. That these possibilities exist calls into question the so-called Antibiosignatures at large, which are a group of atmospheric scenarios that would rule out an exoplanet from being inhabited by life. For example, Venus. Normally this would be the last place one would expect to find life. If Venus were a distant exoplanet, the crushing heat and pressure would probably preclude it from being considered a candidate for a world inhabited by life. But the specific conditions Venus was subjected to over the course of its history changes that equation. Venus is suspected to have once been very different, possibly a water world like Earth for a time earlier in its history. If this was the case, then that's the first criteria for Earth-like microbial life to have its genesis. If that life adapted to the changing conditions of Venus, it's possible that it could still be there, high in the upper atmosphere, where conditions aren't anything close to as harsh as that of the surface. Another example is Jupiter's moon Io. Again, this wildly volcanic, radiation-bathed moon wouldn't intuitively be considered as a candidate for microbial life, but actually it is one. Io once had as much water ice as any of the other Galilean moons of Jupiter, and deep down may have small amounts under volcanically heated conditions. While a huge long shot, in fact probably the longest shot of all the candidates for microbial life in the solar system, it is in principle possible for life to be eking out a living deep down in a moist, warm Io lava tube. These kinds of scenarios where a body's unique history gives inroads for life will make it very difficult to definitively rule out life on some exoplanets that might otherwise seem too harsh for it. Life on Earth has proven to be ridiculously resilient and adaptable once it gets a foothold, particularly the microbes, so it may well be that only the harshest antibiosignatures can be used to definitively rule out the possibility of life on certain exoplanets in the universe, even ones rich in gases like carbon monoxide. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently musing about Anna and my personal carbon monoxide factory, the LeBaron. She thinks it would run more efficiently on hydrogen, which is highly flammable, but I would prefer to remain alive, and be sure to check out my books at your favorite online book retailer, and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.